All right, good evening, everybody. Just wanted to, if you can't hear me, just say something in the chat, but I think everything is set up properly. Um, so without further ado, we'll go through today's agenda. We'll talk a little bit about me, why I decided to create this presentation, and why I love to use Windy, especially when it comes to flight planning. We'll talk about different types of weather models and what a model is and some of their limitations. The next item we'll be talking about are data layers, and these are the layers that you can overlay on top in Windy, and which layers are helpful for flight planning or not flight planning, to be honest with you, if you're doing any sort of other activities outdoors. I also wanted to point out something special about climate change and how it's changing the aviation space a little bit. I've been personally affected by forest fire smoke in a flight that I did this past June that I want to talk about, and how I've incorporated that into my pre-flight planning checklists. We'll also take a look at some of the real-time data layers that are available in Windy, such as the weather radar and satellite imagery. We will also take a look at how to use Windy's trip planner, which is really handy for doing cross-country trips. And then finally, we'll do two example trips. One is going to be around like a 500 nautical mile cross-country trip. And then another one is going to be a local sightseeing trip that I like to use as an example for when you're bringing up, friends to take a look, to do a flight around the city, or, someone who's not maybe that comfortable being in a small airplane. These are some of the layers and the tips and tricks that I use within Windy to kind of determine if the flight would be an enjoyable flight for someone who's not maybe necessarily comfortable in smaller airplanes. And then at the end, we'll have an opportunity to ask any questions. But feel free to ask questions in the chat right away during the presentation if you want me to go over something again, or if you need some clarification about a specific topic. A few housekeeping rules. So just for privacy reasons, the video will be disabled by default. Since this presentation is being recorded for other people to use, I didn't think it was it was a good idea to have everyone's faces plastered all over the internet. So video is going to stay off by default. And in order just to keep the presentation without any distractions or noises from you all have been muted as well. But at the end of the Q&A question period, I will give you the ability to unmute yourself if you do have a question that you would like to ask verbally as opposed to using the chat. All right, a little bit about myself. I am a Canadian who lives in Toronto. I've been a pilot for about 20 years now. I own a Piper Cherokee 6, who I've lovingly nicknamed Plain Jane. I've had her for about 3 years now. A few things of note: I'm not a meteorologist or a certified flight instructor, and I'm not affiliated with Windy at all. I've had some individuals, ask me personally, how do I use Windy for flight planning? And I thought this would just be a good opportunity to share some of my knowledge with the broader internet community. One of the reasons why I started using Windy was kind of out of frustration with some of the weather tools that were available to Canadian pilots from NavCanada. And one of those particular products was called the Graphical Forecast Area, or the GFA. It's a little bit, the data itself is real time or is up to date, but the look and feel and the interface of it is kind of a little bit dated. And one of the frustrations that I had was that, especially on GFAs that were a little bit more complicated, it was hard to determine cloud bases, types of weather, high pressure system, low pressure systems. So I thought there had to be a better way. And then through some research on Google, I discovered Windy. And to be honest, I haven't looked at a GFA in probably 2 or 3 years. And I do all of my flight planning exclusively with Windy. Now that said, Windy does support the same weather model that NavCanada uses to generate their graphical forecast areas. It's called the the GFS model. So if you are going to use windy to compare against the GFA, there are some things that you need to take note of. So obviously the valid at time, in this case, it's the October 17th at 0 Zulu, has to match the same down here. Now, unfortunately, I have it as the 16th and not this, sorry, has to match the value down here, which is 0 Zulu. So I have windy set up to show all the times in local times, but with the Zulu time in the slider as well too. So long as you have that set, then you're looking at the same data for both. And I find that it's real easy. It's so much easier in windy to determine clouds, for example. So if you could take a look on this side here, you have this scalloped layers of clouds to the northwest of the GFA with this front, and you can see that over. Oops, and you can let me go back, and you can see that over here as well on the northwest corner of the map. Same along with this cloud base along Georgian Bay and whatnot. So it's really easy for me to better visualize where the clouds are going to be using a draggable, clickable map than it is trying to determine, where these cloud layers are. Now, if you also notice, windy does have these little green circles, and those are airports, which match up with these green circles, which match up with the circles here on the GFA as well too. So one thing to note is that windy provides a low cloud layer, which we'll talk about later, which is clouds that are between 0 and 6,500 feet AGL, but all the clouds mentioned in the GFA are ASL. So for example, here it says a few between 3,000 and 5,000 ASL. So just keep that in mind if you're trying to compare the two data. One thing I also want to note is that windy just displays numerical prediction results without sort of any human analysis. So whatever the computer predicts it's going to be the weather, it just spits it out and displays it on the map. So one thing that you don't get in windy that you do get in some of the other products available from the FAA or NavCanada are like frontal systems. So this trough here on the west, this will never be displayed on a windy. Cold fronts, warm fronts, occluded fronts, all that kind of stuff will not be displayed in windy, but are in the GFA. So it's still good practice, I guess, to take a look at the GFA as well for surface analysis and frontals systems. But make sure that when you do that, you're using the same weather model, which is the GFS model. All right, let's talk about weather models. So a weather model is a set of instructions or rules that are inputted into a computer to essentially model or forecast the weather. These are things like these super complicated physics equations, and I'm not going to go into, but things about like how the air moves, how radiation from the sun affects daytime heating, all that kind of stuff. Those rule sets are dumped into a big supercomputer, and then this computer slices the world into different regions. And then at each region, the weather is computed at different altitudes in that particular parcel on the planet. So, for example, when you hear about resolution for a model, that is the size of the region that the computer uses to calculate the weather for within that region. So, for example, these are the models that are available in Windy. I think some of them are only available in Windy Premium, which is their subscription service, which, to be honest, is super cheap. I think it costs me like $20 a year. But the top three models that I tend to use are the ECMWF model, which is the European Center for Medium Range Weather Forecasts. And it's considered to be the most accurate forecast model right now. And it's a worldwide model. So it's not just limited to a specific geographic region. The HRRR model, which is the high resolution refresh rate model, which is available only in the United States. They have a resolution of 3 kilometers. So the bigger the parcel of space I was telling you about, so the bigger the square, the more computing power it takes to generate the weather at that specific location. So because the HRRR is a 3 kilometer resolution, which is great, but they only generate it for the continental United States. So unless you're flying in the United States, this particular model is not available elsewhere. And then there's the GFS model, the Global Forecast System model, which was developed by the NOAA in the United States. And it's kind of competing with the ECWF model as being the most accurate. So I think as of 2018, 2017, studies have showed that the European model, as it's also known as, has outcompeted the GFS model for accuracy. The other two models that are available in Windy aren't so helpful, or for me specifically. I found that the North American model and the ICON model, which ICON is the model that was developed by the Germans, doesn't seem to be as accurate in my experience as the European model or the GFS model. All right, let's get to the meat of it. Data layers. So see, these are some of the common data layers that I like to use in Windy for flight planning. So wind, obviously, is super important. So Windy offers you surface level winds and winds aloft at different pressure levels. It's great for using runway direction and determining what your cruise winds are going to be aloft. Pressure, the pressure data layer is great for determining fronts, low pressure system, high pressure systems, and then associated weather that's going to be involved with them. I use cloud-based layer almost every single flight. Since I'm a VFR pilot, it's great to know what the ceiling heights are going to be for flight planning. I know one of you guys had questions about determining visibility. So yeah, Windy does have a visibility layer. This is just for the surface only. And it will display in statute miles what the visibility will be in that particular region. And I'm going to go through all these layers in a moment. Thermals. Thermals is a experimental layer within Windy that I use to determine at what altitude I need to be at to avoid daytime heating turbulence. So the thermals layer shows you at what elevation the thermals will rise to. And traditionally, I guess if you're in a thermal, it's because of the hot air rising from the surface that can cause some turbulence. So long as you're above that altitude, you should have a smooth ride. Then there's the aerosol data layer, which I now use for determining where the smoke from forest fires are going to be, but can also be used for determining the volcanic ash plumes from volcanoes that are erupting. Excuse me. The freezing altitude layer is great for IFR flights to prevent airframe icing. The temperature layer I use mainly at the 500 millibar level, and that's flight level, I think 180, to determine air masses. So if there's a cold air mass coming in from the Arctic, from up north, or if there's a warm air mass, it also helps me determine where the jet stream is going to be. And then rain and thunder. Rain and thunder is just a layer that can show you the location of convective and non-convective rain. Now, keep in mind, this is a prediction of the rain and the thunder and not the actual where it actually is. That would be the weather radar. So I know some commercial meteorology companies like to use the term futurecast or future radar. That's essentially what this layer is. So let's take a look at them in action. So by default, when I log into Windy, I think this is just my setting. I have two important things that are turned on. The first one is the pressure ISO lines. I like to see where the pressure systems are. So I turned this particular layer on. The particle animation is just kind of a fun thing. It shows you the direction of the winds. So it can be helpful in determining just the direction of the wind. And I use the color codes for the speed of the wind. On the bottom right-hand corner here is your legend. And if you click on it, it'll change it to different scales, meters per second, miles per hour, kilometers per hour, knots, because this is for flying. Visibility. All right, cool. So if I go under clouds and I click on visibility, so this is showing you surface visibility. And if you just click on a particular spot, it'll tell you how many miles is predicted. Again, this is not like actual data. This is what the model is going to predict, what the surface visibility is going to be in that particular area. And of course, if I move the time slider, you can see how the data changes as this low pressure system moves through the area, visibility improves. So any of the layers, you can use this like spot picker, just pick a specific spot to tell you what the particular conditions are in that location. So let me turn off my phone. All right, cloud bases are another one that I love to use. And here they are. So cloud base is the lowest altitude of which the clouds are going to be at. So again, you can kind of just like click and drag depending on what area of interest you're in. Blue is low. And again, like by the scale, the bottom right here, you can tell. And pink is obviously the worst. Now there is another layer called low clouds. And you can kind of see that they are lined up, but not quite. So for example, here, it's showing a cloud base of 23,000 feet. But if you click on low clouds, it says 0%. That makes sense. If you ever want to know what each layer means, you can click on the little info icon. And the low cloud layer, for example, covers clouds between the surface and 2,000 meters, which I think is 6,300 feet or something like that. So because the cloud bases are higher than that, they don't show up in the low cloud layer. Alternatively, there's a cloud tops value. This is great, I guess, for IFR flyers, and tell you where the tops of the clouds are, where you're going to pop out. Handy again for IFR flights. The freezing altitude layer is a little bit hidden. I think I forgot to turn it on. There it is. Oh, cool. Now the thing with the freezing altitude layer is that it overlays it with the pressure isobars. I don't find that too handy. So if I click on the more layers, oh no, wait. If I click on the more layers here and I scroll to the very bottom, there is a freezing altitude isoline layer that's more helpful. So that way I can see, 11,600 feet, 3,100 feet. I can see the isotherms on the map, which is what I'm more traditionally used to seeing on the GFS, the GFA and other products from NavCanada. So we got a question from Tom. Yeah, so the cloud bases are AGL in Windy. So just keep that in mind. They're not ASL. And I can just double check for you right now. Let's give me clouds, cloud base, info. Right here. So the cloud base is the height of the lowest cloud base above the ground. So if you're unsure about what layer, if it's using ASL or AGL, you can always click on the little info box. And it'll tell you what if it's AGL or ASL. But I think with Windy, it's all AGL in all cases. Good question, Tom. Temperature. All right. Awesome. So the temperature is this by default, it's going to be at the surface. But if I move this up to 500 hectopascals, this is a good way of seeing air masses. Oh, let me just change the freezing level back to pressure. There we go. That makes sense. So there's a high pressure system there. So this is a good way of determining, if there's a cold air mass moving in, as you can see that there is later this week, as it sweeps across the United States and Canada. I only use this layer just to have a better idea of what the kind of upcoming weather is going to be in the future with regards to temperature, if it's going to be a cold spell or a hot spell. But usually I just use the surface temperature just to determine, like, it's more just what kind of clothes I'm going to wear where I'm flying to. So, but definitely at the 500 millibar level, it's handy to determine air masses. Wind, the most important thing. All right, so wind. By default, it's at the surface. So this is handy if you want to know what runway is going to be in use, as well as what direction the wind is going to be in. Now, there is a wind gust layer as well. I use this occasionally. I find it to be of, within 2 to 3 knots of accuracy. So say, for example, if I'm flying into Detroit, it's the wind is supposed to be 5 knots, gusting 13. It's just another tool for you to help you plan with your flight planning and which runway to use. I don't tend to use wind gusts that much, but I do use wind quite often to determine what it's going to be predicted to be at my destination. Now, for winds aloft, which is very important for those long cross-country flights, you can drag the altitude slider up to different altitudes. So we got 2,000 feet, 2,500, 3,000. Let's go to 500 feet. Let's go back to now. So, and we'll talk about this more in the flight planning section of the presentation. But as you can see, at 5,000 feet here, we've got 40 knot winds coming from 230. So that's quite the headwind at a cruise altitude that I probably would normally cruise at. So this is a very, very, very handy tool in order to try to avoid headwinds. And I've done this before on my long cross-country flight to Arizona. By either waiting it out or trying to plan a route around the stronger headwinds. So, for example, maybe heading further south and then heading west. And we'll talk about this more in the flight planning section later on. But yeah, again, you can drag the elevation or the altitude level up to different cruising altitudes if you like. I have a question about how do you display the wind direction on the indicator? Are you talking about this 230 wind direction? I think it just appears automatically when you click on the map. Do you not see that on your map? And are you using? Oh, you see northwest. Okay, yeah, good. All right, good question, Shane. So I believe that is under your settings section on the left here. And where is it? Show weather picker contains display directions as numbers. There you go. So you had yours set to northwest, or yeah, so see southwest. If you switch that to number, I'll show you the absolute value. Cool, awesome. Another good question. Thank you. All right, and then the last 2 layers I want to talk about are rain and thunder. So this is like that Futurecast or Future Radar products that I want to talk about. So this will show you the predicted areas of precipitation and the intensity. Now the thing you have to know, the intensity is like it's relative. Like, this is how much rain is going to fall in 3 hours, but it's still a good idea. It's still a good indication of how heavy the weather is going to be, or how heavy the rain is going to be. If it's going to be snow, you'll see the snow overlay here. And if it's convective or thunderstorms, you'll see the little lightning bolts here as well. And again, this is all forecasted precipitation. not actual precipitation that's happening right now. And then where is it here? Clouds. If I just go in the default cloud layer, this is kind of like a overall view of the clouds and the precipitation at the same time. So it gives you multiple layers together. But if you just want to isolate just where the rain is going to be, you can just click on rain and thunder instead of clouds. I think I covered everything. Oh, right. So the last thing I wanted to mention was the air quality or the aerosol layer. And this is a layer that I use to determine smoke aloft. It's not very exciting right now because there's no forest fires. But if you take a look here, you can see that there is potential smoke aloft in this particular region. Now, these numbers don't really mean much with regards to, there's no correlation between how much, what the air quality is and how much visibility there are. But in my personal experience, anything that's kind of like a yellow or like a 1, anywhere close to a 1, I've lost the horizon flying VFR. And I can't see, I can't discern the ground from the sky. So the important thing is just take a look at this and make sure that the area you're going to fly in does not contain any particular aerosols or smoke, if that's your concern. And then I have a question. Are the PPT values indicating the forecast per hour? I'm not quite sure what you mean by PPT. Are we talking about rain? Yeah, precipitation. Yeah, okay, let me go back to that. So this value here, like 12.3 millimeters, that's per 3 hours. So that's what I was trying to get at. It's not like a per hour measurement. It's what they predict the rain is, how much rain is going to fall in 3 hours. So in this particular case, it would be 5.8 millimeters would have fallen over the course of 3 hours in this region. Does that answer your question? Awesome. Great. Cool. Let's move on. Okay, so yeah, my segue about the smoke, climate change. So there's 2 main factors that I've in my research that would, I guess, impact aviation directly with regards to climate change, which are the increased incidences and intensity of forest fires, and also the number, not necessarily the number of hurricanes, but the intensity of hurricanes. Now, I mean, forest fires affect us pilots, I would say more regularly than hurricanes do. But they're still important to mention hurricanes because their intensity is planning on increasing, which means more damage, which means more infrastructure damage with airports, flood damage and whatnot. It might affect you as a pilot, and considering maybe having to move your airplane from an airport that may be affected by a hurricane, or you may not be able to return as quickly as you thought. But one of the things you got to consider about forest fires is, as I mentioned, the surface visibility will most likely not match the visibility aloft due to the ash and smoke that are potentially in the area. As well, aerosol ingestions from the forest fires can affect engine performance or even the crew. Like, I don't have any sort of air filters in my Cherokee 6. And you can definitely smell the smoke when, after I took off, after I reached like 4,000 feet above the ground. So if it's bad enough, it could definitely affect your performance as a pilot. And again, I'll give you an example of what happened. I took off planning on having lunch with 5 other people on the airplane. So we're fully loaded with 6 people. Headed north to a really cool restaurant in Aurelia. And I just couldn't see, at one point, I just couldn't see the difference between the sky and the ground. And I was, flying VFR. And I was just like, oh, fuck. Like, this is one of those situations where I got to make a decision. Do you continue on hoping that it's going to get better? Or do you turn around cut your losses, and just go to plan B. Wait for this fire truck to go by. Sorry. So yeah, I decided, you know what, just turn around. Let's have lunch in the city instead. Play it safe. And then when I got back home, I'm like, what did I go wrong? Like, I did all the flight planning properly. I took a look at the METARs at the airport. It said that it was going to be, you know, greater than 6 statute miles, sky clear, but obviously was not the case. So these forest fires in Ontario and Canada definitely affected Southern Ontario and even New York quite a bit. And this was something that I experienced firsthand that I've now added to my summertime pre-planning checklist. Take a look at the aerosol level on Windy to make sure that I may not be affected by smoke from forest fires. And I'm not the only one who's had issues with this. A couple of years ago, in Truckee, which is just near Lake Tahoe, 6 people died because a aircraft was trying to do a circling to land procedure. Hang on one second. I'm just going to mute myself. Sorry about that. These fire trucks are going crazy. I was trying to do a circling to land approach and ended up crashing because they couldn't see the airport due to obscuration by smoke. And again, the METAR said that they had the proper visibility to do this particular approach. However, on the ATIS, it was noted that local visibility might be different due to smoke in the vicinity. So this is, again, something just I want to make sure everyone's aware of, that especially in the summertime in North America and even in Europe, smoke is quite a big issue when it comes to flying. And the other cool thing about Windy is that they've got a hurricane tracker. So if you are in an area that hurricanes can be that affect you, Windy has a great hurricane tracker. And I can just show you that real quick. If you click on the left-hand side here and click on hurricane tracker. That's not a very interesting one. Here we go. You can see its past path, its predicted path, if it's going to hit landfall, what category it's going to be, all that kind of stuff. So this is definitely a tool that I don't use very much because I'm in the Northern Canada. But if you live along the coast, so Florida, the Carolinas or whatnot, this could be definitely a tool to help you predict hurricanes and where they're going to be. One thing I do want to note, though, Hurricane Otis, which was a hurricane that, is he still on here? No, because he's done. It was a hurricane that was on the West Coast. I think it was near Acapulco. It is the first hurricane in history to go from a Category 1 to a Category 4 hurricane in less than 12 hours. So just to kind of further my point about how climate change is affecting the intensity of hurricanes, they've never seen a hurricane intensify this quickly before. So it's just definitely something that's changing our environment quite a bit. All right, let's take a look at the real-time data that's available within Windy. We have access to METARs or METARs and TAPs, satellite imagery, both visible and infrared, as well as real-time weather radar with lightning strikes. So let's take a look at that. Let me just go back to my. So if you turn on the aviation or the airports layer at the bottom here, all these green circles that you see are airports, and they're color coded. So red airports are IFR, green airports are VFR, and then pink is light IFR. So if I click on one of these, or if I just hover over it, I get the current METAR. If I click on it, I get the previous METARs plus the TAF as well. If you guys are lazy, you can just go and turn off the raw mode and it'll have it automatically parsed for you. But they also have access to NOTAMs as well too. So Again, I mean, like this is information that's available within whatever flight planning software you use, whether it's ForeFlight or Garmin Pilot. But it's also kind of nice to it's nice and handy to have that here if you need it. So those the radar and satellite are the two real-time data layers. So let's go to satellite first. Let me zoom out. So you have three options. You have the visible layer, and then of course you have the infrared layer. Good point, Sean. Yeah, or Shane. Yeah. So let me go back to that. There is a cameras option, webcams. Okay, that's the street. Let me give you find an airport that's got. Hold on. I think Toronto or let's do. Yeah. So there's the webcam section that you can take a look at that shows you photos of the sky conditions and the airport as well. So I know a lot of people who use this. I don't, but maybe I should start using this more often. It's definitely handy to see what the conditions are at the airport, especially if you're doing like a local flight. So yeah, thanks for bringing that up, Shane. All right, satellite. So yeah, so two main layers are a visible layer and the infrared layer. And again, the legend for what each color coding means on the right-hand side. And then of course you have the spot picker, which will pick the temperatures for the particular location. The visible is, of course, visible what you see, not necessarily what the water content is. And then you can go back as far as 12 hours, and you can play that back. It's kind of cool seeing the sunrise and then seeing it sunset. But this is handy. I use this for VFR flying sometimes just to see where the cloud cover is going to be if I need to go over a mountainous area and I'm not quite sure, and I want just clear skies. But the one I use the most is the weather radar. Again, this is for real time, so I can play this back and see the direction of the precipitation and where it's going. So if I'm waiting out a storm at a particular location, I usually use this layer just to see where the precipitation is falling and where it's going. And let me see if I can find a more interesting storm. Here we go. So this is obviously a frontal storm. And you can see where the lightning strikes are going to be as well too. So that's handy. If I pause this and I keep it to right now, so it's going to show you the real-time lightning strikes as well, which is kind of cool if you're into that. But yeah, those are the two real-time layers within Windy that are available. All right, let's take a quick look at the trip planner. So to use a trip planner in Windy, all you got to do is right-click on the starting point and then select distance and planning. And then you'll be able to draw your route along the map. And when you're done, and we'll go through this in a little bit more detail, you're given a pretty interesting profile view of the weather you're going to encounter along your route. So starting from the bottom, dew point spread, handy for determining cloud elevation. I don't use that very much. Surface visibility, which is for me more important at my point of departure and my point of arrival. But cloud bases, as a VFR pilot, I like to keep an eye on the cloud bases as I'm flying. Cloud tops, it's great for your IFR pilots out there. Now, the second portion of this graph, you see this brown like line here. That's the elevation. That's the ground. So this is a kind of a boring example, but in the more mountainous regions, you'd see, peaks and valleys. And then these dashed lines are different altitudes, so 3,000 feet, 5,000 feet, 6,400, and the winds that are associated at each level. And then, of course, you have the cloud cover as well. depicted on here. So if you want to avoid flying into clouds, or if you want to know how thick the layer of clouds are, this is definitely a good view to use. And what you don't see here is there's also a freezing level marker. So since it's above 10,000 feet, it's off. It's off this graph. One thing that you can do also is you can set your cruise speed. So in this case, I have it set to 140 knots. And all that does is it just gives you this window here where it says start and finish and the duration of the flight. And allows you to move your mouse along the route, and the map will automatically adjust hour by hour as the flight progresses. Now, one thing to keep a note is that this is just this doesn't take into account winds aloft. So this is just going to be what your ground speed is going to be. So not what your indicated airspeed is going to be. So just keep that in mind when putting in a value here. So usually what I do is I'll go in for flight, do my planning there, and if it says okay, it's going to take me so much time, I divide that by the distance, and I use that as ground speed to put in here just to get a more accurate representation of the amount of time I'm going to be spending in the air. All right, cool. So let's go through our first cross-country flight. So today we're going to be doing a VFR flight from Toronto to St. Louis. We'll talk about the weather that is expected along the route, some sort of mitigation strategies with avoiding rain and low cloud, and also optimize the route for headwinds or tailwinds. I literally just took a look at this like 5 minutes before this presentation started. So I wanted to pick a trip that was kind of interesting and not just like, no precipitation or no clouds. So let's start. So let's go back to Toronto. So I right click, distance and planning. And then I got to find St. Louis. Where is it? Or you can do this. You know what? Let's just go for a general vicinity. Doesn't really matter. Oh, that's why I couldn't find it. There it is. Okay. So let's change the, oops. Why? Sorry, I made a mistake here. Distance and planning. All right, let's go VFR. And let's change that to rain and thunder. And let's go back to 7 o'clock today, just to match. There we go. Cool. 40. Okay, cool. So, as you can see here, as I drag my mouse across the horizontal view, the marker along my route changes. So this is great for figuring out at what point I'm going to hit the particular weather along the way. This brown line here obviously is the ground. So if I'm planning on cruising at 5,000 feet, I have no issues avoiding the terrain, but I will run into some cloud. About 200 nautical miles into the flight, and that's correlated with the cloud bases being between 5,000 and 6,000 feet along this route here. So I've got a few options if I want to avoid this particular section. Obviously, I can move my route a little bit further south, right? So I avoid that rain and those lower clouds altogether at 5,000. Or I can just wait until a different time of day by dragging the slider like that. Now I go to clouds and I go to low clouds or cloud base. This matches up with what I see down here too, right? So this is, as my mouse pointer is over this portion here, it says 4200. If I click, oops, this area here is going to be, the cloud base is going to be at 4200. So you can change all the layers that we talked about before during this flight planning tool. The other thing that you want to take a look at are the winds aloft. So let's change this from surface to say 5,000. So, if you want to avoid headwinds, I mean, in this particular example, it's kind of, I mean, we're departing Toronto, so we need to figure out a way, we need to figure out a spot that's a little bit less windy. So again, you can drag your pointer and adjust your route for fuel economy, right? So this portion of the route is going to be less windy at the time that we arrive. So this is one way that I've used to kind of route myself around, very, very, very headwinds. I had a trip when I went to Arizona last winter, and it was in February, and I had like 50 knot headwinds. My biggest concern was just fuel economy and not necessarily speed. So I don't mind, flying a little bit longer, a longer distance, more route miles, than doing direct. But at least I saved on fuel because I wasn't having such a big headwind. So definitely using this tool with regards to both the precipitation and the wind layers are the two ones that I use the most. If you click on the IFR one, it's similar, but it shows you the freezing altitude, but it also goes up to flight level 450, which is not pretty handy for VFR pilots, but there is also a IFR layer as well, or option as well too. And then the airgram one is just, again, more so for, I guess, knowing at what levels the temperature and the wind direction is going to be. But I mainly just use the VFR tool most of the time. Any questions on this at all? I believe this is available both for the mobile version and the desktop version as well, too, this flight planning, flight routing option. All right, so my local sightseeing flight, we're going to be doing a flight on this Saturday. It's going to be a sunset flight. It's going to be about an hour or so. I would like to make sure we have good flight visibility, and I also want to maximize passenger comfort, trying to reduce the amount of turbulence and bumps as much as possible. So let's close this tool and take a look at Toronto. We're going to do a city tour around the city. Say Saturday, I said, right? Around sunset. Question. I'm just reading the question. Yeah, so the question is, so is there a way to take your flight route that you've planned in Windy and transfer it to your app of choice, which is ForeFlight or Garmin Pilot? So my workflow usually is I've already figured out what my flight is going to be in ForeFlight. And then I put that into Windy by clicking and dragging, by putting them in here. And then when I adjust the options based on, like, if I want to avoid weather or whatnot, then I kind of find a fix or a nav aid that's close to that point in ForeFlight and then add it. So I kind of do the opposite. But if you click on the more options section, there is a export GPX. So if you can import GPXs into ForeFlight, I'm not sure if you can or not. That might be an option for you to import it in. Similarly, if you can export your route as a GPX from ForeFlight, then you can import it into windy here, and then it'll automatically update it on the site. So I think that kind of answers your question, but I haven't actually tested that or know if it actually works or not. All right, let's go back to this local flight. So wind Friday, Saturday night. So I want to do a sunset flight. Right. Okay. So if it only imports KMLs, then I think there is a export KML option here. So you can't import KMLs, but you can export the KML from Windy into ForeFlight. All right. So Saturday it's 5 o'clock. So the first thing that I kind of look at is the where is it? Thermals layer. So kind of this for me is more for like passenger comfort. If I spot click on the map, it says that the thermals are going to be at 4,100 feet. Now, this is an experimental layer from Windy. And the idea here being is that this is at the peak or at the top of which the thermals are going to rise until. And usually that's due to daytime heating. And in my experience, it's kind of bumpy, a little bit bumpy, nothing crazy below whatever this value is. So obviously I can't climb the 4,000 feet in and around Toronto due to airspace restrictions for a smooth flight. But at least I can expect, or I can let my passengers know ahead of time that it might be a little bit bumpy and there's nothing to worry about as we do this tour around the city. The other option is if this is something that's really concerning you, we can just move the slider to a different time of day, right? Look at 8 o'clock or 6 o'clock. So that daytime heating has been reduced. The thermals are going to be less. It should be a smoother ride. And we're still within daylight at 6 o'clock. So maybe this might be a better time to do that sightseeing flight. The other thing that I like to look at for doing local flights, sightseeing flights, is again low clouds. Just people want to take good pictures. They want to have good visibility. This is going to be a great day to do a sunset flight because there aren't that many low clouds to the west. And if you want, you can go to the cloud base layer to see, 32,000 feet. So they should have a great, sunset to take photos of while you fly around the city. And then, of course, I just want to double check to make sure there's no precipitation forecasted, at all, just to make sure that people stay dry and it's an enjoyable flight. And with that said, the presentation is over, but I am open to any questions that you may have about the presentation, or if you want me to go into detail, into any more detail, you're more than welcome to ask any questions that you have. And I just need to, and you're welcome to speak as well. You should be able to unmute yourself if you like. All right. I mean, I did a good job, right? No questions? Awesome. So that said, thanks, Tom. That's it. Thank you very much, everybody. There is a post event survey that I would like you to fill out if you have the time. It just gives me an opportunity to tweak anything I need to tweak. And if there's anything I need to work on or any kind of topics you want me to come up with. It's completely anonymous and completely optional. And also the copy of the slides and this recording will be available on my website. I'll send out the link to everybody who attended. It's going to be up. It shouldn't be up for another couple of weeks though, because I want to do the rest of the presentations that I have in place first before I put them up. But thanks everyone for joining, and I hope you have a great evening.
Thank you very much.